Now we are going to talk about the properties of definite integrals. Let's look at the first property. The integral from a to a of f of x dx equals 0. Okay, so why this is true? So look at this graph. This is f of x. This is a. So from a to a, so which is a straight line. So the area of the line, which is 0. So this is 0. If the lower limit equals the upper limit, the integral would be 0. 2. Integral from a to b of f of x dx. If we interchange the lower limit and the upper limit, becomes the next b from b to a f of x dx. So this would be negative. So if you interchange the upper limit and the lower limit, then you will have a negative sign. This is the second property. The third property. If you have a integral from a to b, k is a constant times f of x dx, it's equal to k times the integral from a to b of f of x dx. You can take the constant outside the definite integral, like we did for the indefinite integral. 4. The integral from a to b f of x plus g of x dx. This one is equal to the integral from a to b f of x dx plus or minus integral from a to b of gx dx. So this problem tells you that you can separate to take the definite integral for each term. Then you add them up. The fifth property, which is if f of x less than equal to g of x, then the integral from a to b of f of x dx less than equal to the integral from a to b of gx dx. Okay, so this property tells you that the integration will keep the inequality sign. So let's look at the geometric meaning for this inequality. So this is a gx, right? Y equals g of x. This is the y equals f of x. They have the same integration limits, a and b, right? So the integral from a to b of f of x dx, which is this area, the integral from a to b of gx, which is black region. So it's obviously the black region is greater than equal to the red region. So this is this property. And 5, 6, 6 is the special case for the property 5, which is if f of x is greater than or equal to 0, then the integral from a to b of f of x dx is also greater than or equal to 0. So here you compare 5 and 6. Here is 0. Here is g of x. If you let g of x equal 0, this would be 0, right? This definite integral is 0. So here is something, the integral from a to b of 0 dx equals 0, right? It's the 0 times the integral from a to b dx. So what does this mean? This means the integrand is 1 here. So no matter what this number is, this 0 times a finite number equals 0, right? So this would be 0. If you use the geometry, right, this is a to b, f of x equals 0. From here to here is f of x equals 0. So this is a line, so the area which is 0. Okay, so you have the property 6. Property 7 says the integral from a to b of f of x dx is equal to, we can plug in a number c from a to c, f of x dx, plus from c to b, f of x dx, where c is any number. It's not necessary to be the number between a and b. It could be less than a, could be greater than b. Okay, outside the interval a, b, it doesn't matter. So now let's look at the geometric meaning for this property. If c is between a and b, what happens? So this is the ab, right? Then the integral, which is this red area, this is the integral from a to b f of x dx. If we insert a number c, let's look at this region, the left region. The left region is actually the integral from a to c of f of x dx. The right region is the integral from here to here. The right region is from c to b, f of x dx. So this red region, the area of the total region, which is the integral from a to c plus the integral from c to b. Right. So, and here this c is between a and b. We have the geometric meaning. Of course, this is also true for c is outside a and b. So c could be any number. So very important. So now let's look at the application, one examples for the property 7. Which is the integral from 1 to negative 1 to 1 of the absolute value x times dx. So now we still use the geometry. So the absolute value have the graph which looks like this one. This is the f of x equals the absolute value of x. From -1 to 1, -1 to 1. Which is the signed area for this region. So here is 0. So it's actually this red region, the red region which is the integral from -1 to 0, the absolute value of x dx, right? Then the blue region is the integral from 0 to 1 of the absolute value of x dx. So the black region is, this is the black region, right? The original one is the black region. The black region is equal to the red region plus the blue region. So actually, this we actually insert a number 0 between -1 and 1, right? For the red region, so it's not hard to do the calculation, right? The red region have the area which here is 1, here is 1, so it's the 1 times 1 times 1/2, right? This is the 1/2, which is positive because it's above x-axis, so it's the 1/2 plus the blue region is here is 1, here is 1, so it's 1 times 1 times 1/2, which is also 1/2, and this region is above x-axis, so this is the 1/2. So it's equal to 1.